Hello and welcome back to Soils, the unit on organic matter and soil organisms. In the previous class we talked about the types of organisms that exist in the soil and the importance they play in the role of organic matter decomposition and cycling of nutrients to plants. Today I'm going to start by talking about how we determine the organic matter content of a soil. When a soil sample is taken and sent into a laboratory for organic matter analysis, there's a specific procedure that is utilized to determine the organic matter content of that soil. That procedure usually involves the digestion of the organic material to separate it from the mineral matter in the soil, and then the total amount of carbon in that sample is determined through analytical chemistry techniques. Why can we analyze for carbon content and determine from it the amount of organic material that exists in the soil? Well, carbon is a relatively constant fraction of the dry weight of organic material in the soil. And for the purpose of analysis, the figure of 58% carbon content is normally used. So this soil sample is taken, typically from the topsoil or the upper portion of the soil profile, sent into the laboratory. The organic material is digested from that soil, and then that extract is utilized to determine the total amount of carbon that is found in that soil. If carbon is 58% of the content of organic matter, we can then take that 58% number and use the inverse of that, which would be 1 divided by 0.58, or a number of 1.72, to determine the organic matter content of the soil. In other words, 1 represents 100% of the soil organic matter dry weight. Carbon represents 58% of its weight. So by dividing 1 by the decimal 0.58, which represents 58%, we end up with a multiplier of 1.72. This 1.72 can then be used to multiply times the total grams of carbon that are found in that soil. So if we determine the carbon content, multiply by our factor of 1.72, that will convert from grams of carbon found in the sample over to grams of organic matter. Now, the only time that this would represent percent organic matter, of course, is if we're dealing with a 100-gram sample of soil. If we're dealing with some volume or quantity of soil other than 100 grams, we would then have to be able to determine percentage. So initially we determine the carbon content. We convert it to grams of organic matter by multiplying by 1.72, and then we can simply take the grams of organic material, divide those by the total weight of the soil, times 100 to get percent of organic material. How much organic material does one percentage in a soil represent? Well, to give you an idea of this, if we had an average mineral soil, and I realize that takes in a very broad range of soils, but for the purpose of this example, let's say that an average mineral soil weighs approximately 2 million pounds per acre 6 inches. So if we have a surface area of an acre to a depth of 6 inches, that would be represented on a dry weight basis of approximately 2 million pounds. Well, if that 2 million pounds contained 2% organic matter, that means that in that top 6 inches of soil in an acre out there, we have approximately 40,000 pounds of organic material. I think you can see that 1 percentage point represents a very large quantity of material, but in comparison to the total weight of the soil, it is not a very large percentage. Once we've converted from grams of carbon to grams of organic matter, and then based upon the weight of the sample that was being analyzed, determine the percentage of organic matter, that would be what would typically be reported on a soil test or analysis report if the organic matter content of the soil were one of those tests that you desired to have ran. Now, why do some soils have high organic matter contents while others have a much lower organic matter content? Well, it would probably be fairly obvious that organic matter content is based primarily upon the type and amount of plant growth that occurs in or on that soil. Now, granted, the organisms in the soil are a part of the organic material, both micro and macro, as well as the soil animals and the soil plant life. but the vast majority of the original organic material is coming from the plants which are growing in or on that soil. So as these plants die, or at least portions of them die, and are returned to the soil, this is a constant source of resupply of organic material into that soil. However, on the other side of that, we have the macro and microorganisms looking at this organic material, this plant debris that's being added, as a source of food. So they're going to be attacking it, breaking it down, converting much of the carbon back into carbon dioxide gas, which goes into the air, utilizing some of that carbon to manufacture more organisms, and remanufacturing some of that carbon into more complex organic types of compounds, such as humic acid, which becomes a part of this total organic matter content in the soil. So one of the primary determining factors as to what the organic matter content of a soil would likely be in a given geographical area is going to be the type and amount of plant growth that exists at that location.